Hi, welcome to our first lecture of Cal 2. Okay, so the first thing that I would like to talk about is a sequence and summation notation, or sometimes we call sigma notation. Okay, sigma, and then you will see that this is actually is the sigma. Okay, and, notation, simple then. Okay, so let's talk about what is a sequence first. A sequence is a set of numbers written in a specific order, like a sub 1, a sub 2, a sub 3, a sub 4, up to a sub n. And then the number a sub 1 is the first term, and then a sub 2 is second term, and so on and so forth. Okay. And then here is an example. Now, for example, like 5, 10, 15, 20, 25, right? Now you will see that here I have a list of number, and then to the list of number here, it seems that we have some pattern, okay? And then you will see that this one is kind of like 5 times 1 to first term, and then we're using a sub 1. And then to the second one is 5 times 2, and the third term is 5 times 3, and then 5 times 4, right? And then 5 times 5. So you will see that here, the number, this number, is related to the subscript, okay? There's 2 subscript, a sub 2, a sub 3, okay? It seems that this pattern right here, we could actually get to a formula, right? Then if I have the n term, and then it seems that the m term will be 5 times n, okay? So therefore, in this case, this is exactly what is meant by sequence now. A sequence is a function f, okay, whose domain is a set of natural number. Now remember, natural number basically is n equal to 1, 2, 3, right? This is the natural numbers. The terms of the sequence are the function values f of 1, f of 2, f of 3, up to f of n. However, we usually write it as a sub n, just like what we did here, instead of the function notation f sub n. Okay, so then this is exactly the idea about sequence. Okay, okay. So now let us look at our first example now. I would like to write down the first 5 terms of each sequence. Okay, so to this one, to A, the sequence name is s of n, and then is equal to n to the square plus 1. So therefore, in this case, if I want to write down s of 1, now remember, we only need to write down the first 5 terms, right? So basically, what we need to do is, it will be 1 squared plus 1. So we know that, of course, this is 2. And then s of 2 will be 2 squared plus 1, so it's 5. S of 3, okay, it will be 3 squared plus 1, so it will be 10. And s of 4, it will be 4 squared plus 1, 17. And then s of 5 will be 5 squared plus 1, which is 26, right? Yes, this is exactly the idea about how we could create the sequence, okay, if we have the function, right? Here, okay? Okay, so now it is your turn. Go ahead and try the problem B. Now, what we need to do, basically, we need to just pause the video, okay, work out the problem. And then after you finish the problem, then you could continue to view the video and then to check your answer, right? Okay. Okay, then now let's check our answer now. So d sub 1, so I will have negative 1 raised to the power of 1 minus 1. And then I will have multiplied to 1 over 2 times 1 minus 1. Okay. Then, of course, you will see that 1 minus 1 basically is equal to 0. So I have 1 to the power of 0, or negative 1 to the power of 0. Okay. And then I will have 1 over 1. Then, of course, my answer is any number raised to the power of 0 is 1. So then my d sub 1 is actually is equal to 1 then. Okay. Okay. Then check out d sub 2, -1, 2 minus 1, right? Then I have 1 over 2 times 2. Oh, I'm sorry, this is a bit 2 minus 1, okay? Then to this one is -1 to the first power. So I have -1 times 2 over 3. So my answer will be -2/3 then. And then now the next one. Okay. So d sub 3, -1, 3 minus 1. And then I will have 3 over 2 times 3 minus 1. Then of course, this is -1 to the square is +1. 3 over 5. Okay. And then let us finish this then. Okay, so then now you will see that the sequence, the list, okay, maybe I could write like this, okay. It is 1, -2/3, 3 over 5, -4 over 7, and 5 over 9, okay. And then you will see that one thing I hope that you notice, this term right here is actually, it will make the sequence, that means the sign is alternating, right? Positive, negative, and so on and so forth. So therefore, again, next time when you see a sequence have positive or negative, then you could use this to again, to help you to create the sequence or to find a function then, okay? Okay, so the next one is actually the one that we need to see the pattern of a list, and then from the pattern, we create the functions of the sequence then, okay? So then let us look at this one, okay? So I have 2 over 3, 4 over 3, 4 over 9, 8 over 27, 16 over 81. So in this case right here, it seems that I found the pattern is kind of like you have 2 over 3 to the first power, and then 2 over 3 to the second power, 2 over 3 to the third power, 2 over 3 to the fourth power, right? 2 to the 4 is 16, 3 to the 4 is 81. Oh, it seems that now I actually have a pattern. And then now we could actually write down the function, right? A sub n is actually kind of like first term, second term, third term, fourth term. So it seems that we could have 2 over 3 to the n then. This is the n term that we have now. Okay, okay, so now it's your turn. Now go ahead and try B now. Okay, so to this one right here. First, I noticed that the sign is alternating, so meaning, and then it starts with the positive. So I have -1 and -1, okay? And then now you will see that basically we look at 2, 4, 6, 8, 10, right? 2 times 1, 2 times 2. So how about I write down 2n then? Yeah, that's it, huh? Okay. Now this is actually the idea about sequence, okay? Now the next one that I would like to talk about, what if I want to have at least, okay, or the summation of the sequence now? So you will see that I would like to have a sub 1 plus a sub 2, a sub plus a sub 3, up to a sub n. Then in this case, we have a notation to talk about that. Okay, so we call it sigma notation or summation notations. So then in this case right here, how do we create the summations or the notation, okay? So we would write the sigma, okay? And then in this case, now you will see that in this case right here, the least or the sequence that I have is kind of like I have a sub n, right? This is actually is the sequence that I have. Because when n is equal to 1, n is equal to 2, n is equal to 3, and so on and so forth. And then now, so therefore in this case, this is exactly why I have a sub k right here. This is the function of a sequence, okay? And then now, you will see that the index, okay? If you are using n, then this will be n. But here we're using k, so this is k. K is from 1 to n. Okay. So this is kind of like the range. Okay. So now, this notation right here, summation k is equal to 1 to n of the function a sub k is the sum of a sub k from k equal to 1 to k equal to n. Then the integer k is called the index or the sum. So this is the index right here. Okay. Okay. Then now, let us look at our first example now. So right now, I would like to, again, to this one right here, I have a summations. So first of all, if I would like to write down k, and then this k right here is from 1 to 4, right? Okay. So then basically the sequence that I have will be 1, 2, 3, and 4. I have 4 terms, okay? So therefore, in this case, if I want to write the summations, basically I'm going to have 1 plus 2 plus 3 plus 4, okay? If this is the case, then of course I know that 7, so it will be 10 then. Yeah, so that's it. So this is actually is the idea, okay? Okay, so now is your turn now to do 3B and 3C now. Okay, so then again, let us look at I square. And then to this one right here, I would like to have it from 2 to 5, right? Okay, so then basically we would like to have a 2 square plus 3 square plus 4 square plus 5 square. Again, from 2 to 5, we have 4 terms, okay? And then each term, oh my bad, is not precise, it should be a comma because it is a sequence, right? It's a list. Then now, if I want to work with the summations, then it will be 2 square plus 3 square plus 4 square plus 5 square, okay? Then of course, this one will be 4 plus 9 plus 16 plus 25. And then it will be 20 and then 34, so it will be 54 then. Now, 3C is a kind of a special, huh? We have a number. Now, one thing about this is, when you look at the index, I is from 1 to 4. Oh, by the way, you see that the index, you could using K, you could use I, okay? Now, you could use actually any variable, okay? Okay, so now, if the index from 1 to 4, it's telling me that I'm going to have 4 terms. So I will have a number plus, right? 4 terms. And then now you will see that because the function is a 3, so meaning what? Each term must be 3 then. Okay, it's kind of special, huh? So therefore, in this case, this number right here, it will be 12 now. Okay. Is that okay? Okay, so now after we know how to actually rewrite from a sigma notation to the summation, right? To sum up the list. Then the next one will be, I would like to see how could I create the summation notation now. Okay, so again, let's see if we have a pattern here. So in this case, the pattern that we have, okay, is kind of like we have 1, and then this is 1/4, 1/9, 1/16. It seems that we have a number square. So I will have 1/2 square plus 1/3 square plus 1/4 square plus 1/5 square plus 1/6 square. Okay. Ooh. Then if I see a pattern, then wait, I will be able to rewrite this equal to the summations. Okay. Then how about if I use the index k, then I could have k is equal to, we have it from 1 to 6, right? So k is from 1 to 6 of the function k squared, then 1/k squared. Okay. Yeah, that's it. Okay. Okay, so now is your turn. Now go ahead and try B, C, and D to see if you could write the summation notation. So you have 2q plus 3 to the q, 4 to the q. Then what we could do here is we could actually start at I is from 2 to n of I to the power of 3 then. How about this one? If, think about this. Could I write the summation like this? I is from 1 to n minus 1. Okay. Of I plus 1 to the power of 3. Is it okay? Yeah, it is okay, right? Because think about this. If I equal to 1, then I have 1 plus 1 is 2, 2 to the q. I equal to 2, I will have 2 plus 1 is 3, 3 to the q, right? And then how about n minus 1? N minus 1 plus 1 is just n. So basically, this is okay then. And most of the time is we like to have I starting from 1. Okay, so that's why sometimes you create a summation notation this way then. Okay, then how about this one? Easy, huh? So I will have I is from 5 to 8 of x to the I. Okay. And of course, I could write it in this way too. I could have summation k from 5 to 8 x to the power of k. Okay. So I just change the index to k. The next one is kind of weird, but one thing that we notice is the pattern is the subscript is 1, 2, and up to n, right? So then in this case, I could use the summation notations. I is from 1 to n of f of x to the subscript I times the delta x. Okay, so yeah, that's it for the first, kind of like the first day lecture is talking about the summation notations and also the sequence. Okay, thank you. See you next time then.